Today I'll be teaching you the basics of important chemistry topics. You will learn the 5 reaction types, percent composition, empirical and molecular formula, and finally balancing. Okay, we will begin by familiarizing ourselves with the periodic table. Here you can find the different types of elements with their atomic numbers and atomic mass. While doing most problems in chemistry, you will refer here to find the mass of certain elements you need. Here we have a key that shows you where everything is in one box on the periodic table. First is the element name, then the atomic number, next the symbol, and finally the atomic mass or weight, which is always measured in grams. Here are 2 examples of how elements are organized on the periodic table. Here we have beryllium. The atomic number is 4, the symbol Be right in the middle, and the mass 9.0122. The mass can be rounded to 9, and the atomic number is again 4. Here we have another example. This is silver. The atomic number is 79, the symbol Ag, and the mass 107.87. Atomic number 79, and the atomic mass is rounded to 108 grams. There are 5 different reaction types I will be teaching you: synthesis, decomposition, combustion, single replacement, and double replacement. We'll start with synthesis. It can be written like this: A plus B yields AB. A real-life example would be like marriage. A synthesis reaction is where 2 or more substances combine to form a single substance. Here is a real-life example. 2H2 plus O2 yields 2H2O. The little numbers next to the HO and the other H are called subscripts. That is how many of each element are in the problem. The H2 acts as an A, plus the O2, which is B, yields to make AB or H2O in this problem. Now let's look at a decomposition reaction. Opposite of a synthesis reaction, a decomposition reaction can be written like this: AB yields A plus B. A real-life example would probably be like a breakup or a divorce. A decomposition reaction is when a single compound is broken down into 2 or more products. Here's a real-life example. 2HGO yields 2Hg plus O2. The HGO represents the AB, which yields to A, which would be Hg, plus B, which would be the O2. Here we have a single replacement reaction, which would be A plus BC yields B plus AC. A real-life example would be like cutting in on a dance. A single replacement reaction is when a single element replaces an element in a compound. Here's a real-life example. Zn plus Cu, NO3 yields Cu plus Zn, NO3 The Zn is the A, plus Bc, which would be Cu, NO3 which yields Cu, which would be B, plus Zn, A, NO3 C. And like a single replacement reaction, we have a double replacement reaction. This would be AB plus CD, then yields AD plus CB. This could be like switching dance partners in a dance. A double replacement reaction is when the cations and anions of 2 different compounds switch places, cations being positively charged ions and anions being the negatively charged ions. Here's a real-life example. AgNO3 plus NaCl yields AgCl plus NaNO3. AgNO3 would be AB plus NaCl CD yields AgCl AD plus NaNO3 CB. The final reaction type is combustion. This one is different than all the other reactions. To do a combustion reaction is simple. The product of the combustion reaction is always CO2 plus H2O. A combustion reaction is always a substance reacting with O2 to release energy. Here's a real-life example. CH4 plus 2O2 yields CO2 plus 2H2O. The last part here represents the answer that's always at the end of a combustion problem. Here are some examples of all 5 reactions. Try to guess which is which. Pause the video and write down your answers. Okay, now we're going to move on to something called percent composition. Percent composition is a percent of the total mass of the compound that is due to that component. Here are the 4 steps to finding the percent composition. Find the mass of the whole compound, find the mass of just the element you are concerned with, divide the mass of the element by the mass of the compound, and finally multiply by 100 to convert to a percent. So let's try an example. Beryllium nitride, Be 3, N2. First, find the mass of beryllium by looking on the periodic table. Beryllium is 9 grams, and the 3 next to the Be means that there are 3. So 9 times 3 equals 27 grams. Nitride, or nitrogen, is 14 grams, and since there are 2, then 14 times 2 is 28 grams. 27 grams of Be3 plus 28 grams of N2 equals 55 grams of BeN2 total. Now you have Be3, you would do 27 grams divided by the total 55 grams. It equals 0.49. You multiply that by 100 to convert to a percent, which equals 49.09 repeating. For N2, you do 28 grams divided by the total 55 grams, which then equals 0.50. Multiply that by 100 and you get 50.90. So for beryllium nitride, there is 49.09% of beryllium and 50.90% of nitrogen, which if you add 49.09 and 50.90 equal 100%. Do this for all of your answers to make sure that your percents add up to 100. That means your answers are correct. Okay, now that you know percent composition, we're going to learn how to determine empirical formulas. Empirical formulas consist of the symbols for the element combined with the subscripts showing the smallest whole number ratio of the atoms. Here are the steps. First, determine the composition by mass. Take the percent composition and set the 100% to grams. Make each element's percentage equal to grams. Second, determine the composition in moles. Divide each number of grams found in number 1 above by the atomic mass of the element. Number 3, find the smallest whole number ratio of atoms. Divide by the smallest number of moles found in number 2 above. And finally, number 4, if your answer can be rounded to whole numbers, that is the number of moles of each. If not, multiply by a small whole number. Okay, here's an example of empirical formula. You are given 25.9% of nitrogen and 74.1% of oxygen. First, set a chart up like this. You have what you're given on top, the grams of what you're given on the bottom to cancel out the grams of what you're given on top, and the 1 mole of the given, which is what you want. So first you set up the 25.9 grams of nitrogen that you're given. You look to the periodic table to find the grams of nitrogen and put that below to cancel out. Then you put 1 mole of nitrogen, which you're trying to find. Multiply across the top, multiply across the bottom, and then divide the top by the bottom. You should get 1.85 moles N. Then for oxygen, you have 74.1%, which you convert to grams. Put that down here first, and then you find on the periodic table that O is 16 grams. You put this on the bottom to cancel out the 74.1. Then on top you put 1 mole O because that's what you want. So you have 4.63 moles of O. Next what you need to do is divide by the lowest number of the two. The lowest is obviously 1.85. So you divide both by 1.85. And you should get 1. And down here you should get 2.5. Now when your answer is not a whole number, you need to multiply it by the smallest whole number possible to get the nearest whole number. So you multiply this by 2, which means you have to multiply this by 2, which means you have N2, because this is now 2. O would be 2.5 times 2, which is 5. This is the answer to your empirical formula. Similar to empirical formula, next you're going to learn the molecular formula. To find the molecular formula for a compound, you need to know the correct molar mass of the substance. The molar mass is also known as the atomic mass. To determine the molecular formula, we divide the molar mass by the simplest formula's molar mass. This gives us a whole number, which you then multiply all the atoms in simplest formula to get the molecular formula. Here's an example of molecular formula. You're given 40% of carbon, 6.71% of hydrogen, and 53.28% of oxygen. Your entire molar mass adds up to 60 grams per mole. So first you take the 40% of carbon, come down here, create a chart to balance out. You calculate this, which will get 3.3 moles of C. Then you take 6.71 grams of hydrogen, put it in the chart, multiply across, divide by the bottom, and you'll get 6.7 moles of H. Then you do 53.28 grams of oxygen. Multiply across, divide by the bottom, and you'll get 3.3 moles O. As you notice, the final answer is CH2O. The reason there's a 2 next to the H is because this is the only answer that is not the same as the other two. This will happen in a lot of problems you do, and if that happens, then you keep these 1. As you see, there's no 1 because you don't need 1. And you put the 2 next to the H. And that is your final answer, CH2O. Our final topic that you will learn today is how to balance an equation. Balancing equations is based on something called the law of conservation of matter. This is when the number of atoms of each type of element must be the same on each side of the equation. The rule is that subscripts can never be changed. Our final topic that you will learn today is how to balance an equation. Balancing equations is based on something called the law of conservation of matter. This is when the number of atoms of each type of element must be the same on each side of the equation. A rule that you must remember, subscripts cannot be changed. Here's an example of an equation that you may need to balance. NaCl plus F2 yields NaF plus Cl2. The subscripts 2 next to the F and Cl make the both sides of the equation unbalanced. To balance an equation, you have to make a chart. Split the 2 in half. On one side, write all 3 elements you see. I see Na, I see Cl, and I see F. You have to remember that on one side, what you write on one side, you have to write on the other, no matter what. Okay, now to balance this, you need to see how many of each element are on one side of the equation. So you put Na, you see 1. Cl, 1. F, there's 2. So you put a 2 here. On the other side, do the same thing. There's 1. You see that there's 2 and 1F. Notice how the numbers are not the same on both sides. So to balance, you need to first make the CL's balance. To do that, you need to put a 2 here. That cancels this, makes this a 2, but it also cancels the Na, because this is in front of the Na also. So to make the Na a 2, and you also need the F a 2, you put a 2 right here. See that cancels, and this cancels. And now both sides of the equation are balanced. Now hopefully you understand how to recognize the different reaction types, how to solve percent composition, empirical and molecular formula, and how to balance an equation. Thank you for watching.